All right, can you hear me? All right. Well, welcome to Friday afternoon, right? It's really foggy outside in Chicago, and it's kind of cool because in a way it's a little bit of a metaphor, right? Because if you know something about Azure, but it's you know something about AWS, and maybe your Azure knowledge is a little foggy, maybe we can clear some of that up for you today, right? So this is the session, Port Your AWS Knowledge to Azure. And that's what we're going to be talking about for the next 75 minutes. But if you don't know a lot about AWS and you just want to hear a little bit more about Azure, that's okay too, because you will definitely get something out of this, right? We'll go through some pretty neat things. Now, I think that just to introduce myself really fast, my name is Dan Patrick. I'm the Chief Cloud Strategist of a company called Opsgility. Opsgility is the #1 Azure training company in the world, according to Microsoft. We've trained more people on Azure in the past couple years than anyone else. And actually, we train Microsoft employees, both their technical people, salespeople, that sort of thing, as well as their engineering teams. We have a website, opsgility.com. You can go check it out. And if you want to learn Azure, you want to get certified, that sort of thing, we have the best goods in the business, so check that stuff out. I was a Microsoft employee for about 15 years. That's kind of like a life sentence almost, so I got out when the product group I was working for was actually sold to a different company. I left in 2012. And since then, I've been doing consulting and training and writing and speaking and things like that. And so I'm really excited to be here today. Now, there is a course also that's out there that I actually was a co-author of called Azure for AWS Experts. I don't know if anybody's ever heard of that class or not, but it's a course that's being offered quite a bit, and I think they even have some deals online on Microsoft.com. So you can follow me on Twitter, at DeltaDan is my handle, and I blog and things like that all over the world. So really excited to be here to talk to you about this. So, it's interesting because, Azure has really come a long way the past couple of years, right? And, when you sort of think about the Azure value prop and what they're going for, is they're looking for people to innovate, right? To take their knowledge in the Microsoft platform and take that to the cloud, right? AWS has been around for a long time. As a matter of fact, they're way out in front of Microsoft in a lot of ways, and Microsoft knows that, respects that, and understands it. But Microsoft has a huge developer ecosystem, right? And system administrators that understand the Microsoft technologies, right? And so, application innovation, data, that sort of thing, bringing data, Microsoft-centric data, but not just Microsoft-centric data. And the third one up here is openness and flexibility. How many of you think of open source in your mind when you think Microsoft? Probably no one in the room. But the truth is that these days Microsoft has become one of the most open companies there are. They're top 10 contributors to many, many extremely important open source projects, like the Docker project, things like that. And many, many things from Microsoft have been open source, like PowerShell, the .NET framework. You can run .NET applications on Linux now. And as a matter of fact, 1 in 3 new VMs that's created every single day in Azure is a Linux VM. Microsoft is very, very focused on this market because, Linux, very popular on the internet. Azure, cloud internet platform, right? And so, we'll talk a little bit more about that later. And the demos that I have for you today are all Linux running in Azure. I'm not going to show you any Microsoft stuff. I'm not going to show you any PowerShell stuff. I'm not going to show you IIS. Okay, I'm going to show you Ubuntu and PHP and MySQL, right? We're going to build some of it with from the portal and some of it with the command line, all right? And then the last is trust. Microsoft has really gone a long way in the past 20 years in trust. One of the things I did when I was at Microsoft, I worked for the Windows product group out in the field on security when we were dealing with horrible security issues. And those security issues and the investment over the last 15 years has been incredible and has really paid off in a lot of ways. So let's keep moving here. So building apps faster and easier. Microsoft has focused on platform as a service, building sort of the next generation of applications where you can develop your application and worry about your app and your data rather than worried about a virtual machine, right? Rather than worried about Patch Tuesday and these sort of really annoying things. I just go into web browser and put my code up there and my data up there, and I say, is it 32-bit or 64-bit? Is it, what version of Java is it? That sort of thing. What version of PHP? And it just works. I only have to worry about my code and my data. Next is IaaS, infrastructure as a service, right? Microsoft's huge investments in this. It makes complete sense, right? Hybrid cloud, if you will. Microsoft has been tremendously successful in the enterprise for the last 20 years, and they're going to continue that, and their innovations are going to continue to grow, and people will be able to, migrate things from on-prem out into the cloud and run them out there. But then more cloud-focused sorts of things, like Internet of Things, cognitive services, the bot frameworks, so more cloud-focused, more AI, more future types of services. And Azure is really the center of that framework and the center of that passion for the future, right? Now the last one is the Azure Marketplace. And if you get anything out of today, having come from AWS, you probably know about the Marketplace. But I challenge you to go out and just search, Google Azure Marketplace and go look at everything that's out there. Because the Azure Marketplace is filled with incredible things. Did you know that you could run like a Cisco firewall in Azure? Or run a Palo Alto firewall or a NetScaler or anything? You can do that very simply. You go to the Azure Marketplace, you look and find it up. There's usually a template that's there. You click create, and before you know it, you've got whatever it is that you're looking to deploy is out there. And that's what the Azure Marketplace is for, right? It's there to get you up and running extremely quickly, right? So, now, I just talked about those open source, and here's a little bit digging in on it. Microsoft, like I said, is really embracive of all of these technologies and all up and down the stack. So anything from infrastructure, right? So we see companies like Red Hat, Docker, DCOS from Mesosphere, that sort of thing, even up into containers. And if you look at all of this across the entire stack, Microsoft hits it, right? Everything from content management from Drupal to DevOps tools like Chef, all the way down, like we said, back to Red Hat. In Red Hat's case, there's deep integration with the portal. So if you have a Red Hat subscription on the Red Hat website, you can go to the Azure portal, deploy a Red Hat VM, and actually leverage the subscription that you have, your enterprise subscription with Red Hat. And if you start a ticket for a Red Hat VM that's running in Azure, the person who helps you is probably a Red Hat employee that's on campus in Redmond. So there's actual Red Hat employees that wake up in the morning and drive to campus to provide support. Cats and dogs living together, right? It's kind of crazy. But it's true. I mean, it really is true, and that's what's so interesting about this. And even parts of the Azure system itself. The software-defined networking layer is run by an open source piece of, well, it's not open source, it's based on an open source product, it's based on Debian. But you can search, it's called Sonic, and it helps to run the networking plane in Azure. It's built on Linux, okay? So the company's really changed, and that's one thing that I think a lot of folks come from the AWS world or open source world, they don't realize how inclusive and how open and how Microsoft wants that to be a part of Azure and wants that to be a part of their future, all right? So let's do this. We're going to port your knowledge, all right? This is what we're going to do. And as we look at the different pieces, what you're going to find is that if you know AWS, you almost know Azure, right, in a lot of ways, because the things work the same in a lot of respects, right? If you know what an elastic load balancer is in AWS, there's a load balancer in Azure, right? And that's what we're going to kind of do. We're going to look at all the different products and that sort of thing. Now, of course, all of these clouds are huge. We can't look at every single thing in a session that's this long. So we're going to focus on compute, networking, and storage, right? It's going to be kind of the focus. But I think you'll get a lot out of this. And what you'll realize is that if you do come in the AWS world, you can come up to speed on Azure pretty quickly, okay? Now, you might get a little bit frustrated because there's some things over in AWS that Microsoft is still catching up on, frankly, right? And they know that, and trust me, they're working extremely hard to get there. But let's take a look first at what Microsoft has built, and it is pretty amazing, actually. So right now, there's 38 Azure, what we call regions, that are online around the world, or that are being built or announced. There's 30 that are online. And this is just an absolutely huge infrastructure. If you see all the green dots on the slide, those are the ones that are operational. The blue ones are the ones that are announced. Very heavy in North America and Europe, and even in Asia, right?
strong presence in all markets. Now, Microsoft in total runs about 100 data centers around the world, okay, all in total. And it is actually about, I mean, they pretty much say it's the second largest dark fiber network in the world, okay? So it's a dark fiber network that they've lit, basically, right? That could really almost be a telecom company if they shut this whole Azure thing down because the network is so large. Now, if you take a look at some of this, like in the US, what you'll see pretty quickly is there's great coverage and more coming in the commercial space, but there's also a heavy investment in the government space. And we'll talk about some of the things in government here in just a moment. But there's currently 2 different Azure regions in the US that are online for government. There's 2 more that are being built. So the current ones are Virginia and Iowa. There's going to be one in Texas and one in Arizona. And when we talk about government, it's not just the federal government. It can be any municipality. So it could be just a town, or it could be a fire district or something like that if they have a need to be in the Azure government. And then there's also 2 regions that are being specifically built for the DoD. And Microsoft just got a really important DoD certification last week, or the week before, I think. And so, you know, they're really pushing into that space to provide there. Now, all of the rest of them, with the exception of a couple too, are Azure Commercial is what we call it. The other exceptions are Germany. In Germany, we have it's called a country cloud, right? So there's a cloud all on its own that's separate in Germany, and it's run by T-Systems, right? And they're the data designee, as it's called in Germany, where they're really responsible for the data, ensuring that the data laws, which are quite strict in Germany, are followed. And then over in China, actually in mainland China, there's 2 data centers that are, once again, completely separated from the rest of the Azure network, and Microsoft doesn't even run them. It's run by a different company as well called 21Vinet, right? So those aren't connected. So the gov clouds and the country clouds are not connected. They're connected to each other, but not connected to the rest of Azure, okay? So that's the way you could think about it. And there was a great announcement just a couple weeks ago. You see the Australia East and Southeast. It used to be you had to have a company that was based in Australia or New Zealand in order to leverage those because of tax and tariff laws, but somehow they figured it out, and now anyone can use those, and they're generally available across the entire world. And if you go to this link down at the bottom, Azure Regions, you can read more about it. Another interesting thing to note about the regions in Azure is not every service is available necessarily in every region at a given time. A lot of times they'll roll out services to 10 or 12, and then it takes a little bit, later for them to filter down to the other ones. So on this page, there's a thing called Services by Region, where you can go and look at the region that you're thinking about using. Does it support whatever technology you're looking at, like maybe container services or, premium storage or something like that, okay? So keep that in mind. Now, if we look at AWS, what we have is sort of a different philosophy in a way. They don't have quite as many regions, so they have 18 announced and 16 online. But these are comprised of what's known as availability zones, right? And so a region in AWS is a little bit different than a region in Azure, okay? A region in Azure is like a mega data center. Some of them have multiple buildings, a lot of them are just one, okay? But the difference is with AWS, a region, if you will, is within a contiguous sort of 50 square mile area, right? And they might have data centers that they own. They could have colo data centers, right? Things like that. And so, their concept is to kind of spread it out a little bit, right? That's their concept. And the other thing that's really interesting to, administrators and people that are rolling it out is, in AWS, you can say where your servers are in a region, right? So if we were to imagine ourselves, if I had, let's just say really easy, I had 10 web front ends, and we were going to roll out to Northern Virginia that has 5 availability zones, I could put 2 web front ends in each one of those availability zones, right? So if Godzilla on a F5 tornado takes out 2 of them or something like that, then I would know where my other machines are, right? So that's something that's a little bit different. Now, coming down here, AWS has a few more regions that are going to come out soon. What I think you'll continue to see is you'll continue to see both companies follow this track. Neither one has really, taken a turn. They've really stuck to this is how it's going to go. And I also don't think that you're going to see Microsoft slow down, right? Microsoft has said that, I mean, anywhere where they could put one, I think they would put one, right? As long as it makes sense financially. So we'll probably see that continue to grow. Now you can surf a link here to go learn about AWS infrastructure. And I hope you'll notice in this presentation that we're not really trying to say one's better than the other or anything like that, right? We're just trying to sort of look at the two, examine them, and help you to port your knowledge and understand it, okay? So to kind of dig in a little bit deeper, if we look at those 38 regions that we talked about, one of the things that Microsoft does is they have what's known as region pairs, okay? So region pairs, the idea is that in a geography, right, like North America or Asia or wherever, in a geography, each one of those regions has sort of a sister region, if you will, right? Have anybody ever tried the geo-replicated storage from Azure yet? Have you? Okay, so do you know where that other site is? It's to the sister, right? It's to that pair. And right now you can't say where it goes, right? So if you're in East US, for example, I just happen to know this one off the top of my head. West US is its region pair. So if I deploy, a storage account in East US, I geo-replicate the data, it's going to send it to West US, right? Or if I created a recovery services vault for Azure Backup or Azure Site Recovery, one of the things that does is it automatically geo-replicates for you. It would go to that region, all right, to that region pair. Okay, so one of these regions for Microsoft is a huge data center, massive scale, that sort of thing. Huge levels of redundancy and all of that. You can go read about it if you want to. We're not going to go into it. But one of the big things that's different between the two is Azure's region-to-region traffic. Meaning if I have a VNet in one Azure region and I have a VNet in another region, it goes across the Microsoft backbone. Okay? It's not the case with AWS. With AWS, it goes across the internet. You have to create like a VPN gateway across the web, right? So quickly to examine this, over in AWS, they don't have these region pairs, right? They're not sort of paired up the same way Microsoft has. So they don't quite do it that way. But they have those availability zones, right? So that's that trade-off because you can see where one has some advantages and the other one might have other advantages. And they're very well built, obviously. I mean, AWS data centers are world-class data centers and have high availability and that sort of thing. So it's not to say that they're not disaster sort of built for that. But that last piece of going over the internet is kind of a big deal, right? I mean, I think it's kind of a big deal. In AWS, you'd say, well, okay, we just sort of accept it. But there are real things to that, right? Like I can't get an SLA between me and past my internet, right? Wherever my provider is, I can't get an SLA past that. But Microsoft gives you an SLA, right? So their network that traffic between regions is on their network, so they give you that SLA, right? Okay. So, and you can go and read about the data centers when you get the slide. So let's kind of map through some of these things just to give you some context of some of the terminologies. So, things like, how do I bill or what's it called? In Azure, we have a subscription. Over in AWS, we have an account. A security principle is called like the subscription or the account admin. In Azure, it's called a root account. You can kind of read down the list here. And I think that some of the ones that might be a little bit confusing is, one's called a region, another called a region, but we just talked that to death. You understand that. Infrastructure is code, as you will. How do you, take some code and build an infrastructure? In Azure, we call that Azure Resource Manager, right? So infrastructure is code. It's called CloudFormation over in AWS. But they're both kind of based on the same types of technology using JavaScript object notation and that sort of thing. And all of these obviously have, tagging and lots of automation and ways to script and do that. And in both senses, they're very mature. And we're going to take a look at things like identity and some of these others here in just a few minutes. So if we examine the government cloud, we talked about the number of regions, and you can see that up there. Microsoft has actually invested a lot in the last couple of years in their government cloud. When it first came out, it didn't have nearly as many services as the Azure Commercial Cloud, but it's come a long way. Even recently, they just announced Azure Site Recovery and Backup and that sort of thing, so you can do DR out to the Azure Government Cloud. But significant investment here, as you can see, so virtual machines and scale sets, premium storage for Flash, that sort of thing. Great hybrid operations, so log analytics, site recovery backup, we just mentioned that a minute ago, as well as a lot of the PaaS services, right? Like SQL, Azure, that sort of thing. And so they've done a really good job of beefing this up over the last year, because frankly last year it wasn't quite as beefy as it is now. Now over in AWS, they're a little bit leaner, frankly, on the government stuff. They only have one region right now, and it's out in Oregon. And they're, what I would say kind of the meat and potato services are definitely there, I mean, the IS stuff, that sort of thing, is very strong and works great. It's not a question of it doesn't work. It's more a question of availability, right? Availability and investment. So, there's great stuff here for sure that's very, very useful to many governments. And when you think about, the millions and millions of systems across the governments, right? I mean, most of them are probably IS services running on a VM, and that's all you need, right? So, that's kind of the key there. But Microsoft, at least from the looks of it on the map, definitely is really kind of more all in here, it seems. Now, when we compare the purchasing and the billing, this is where it gets a little bit interesting. So in a lot of ways, they're the same. In some ways, they're very different. So, Azure has, it's in, I think, about 140 countries. AWS is available like in about 190 or something like that, almost everywhere in the world. And, the one thing that Microsoft does is they've made it really easy to bill. There's about 24 different currencies that you can bill in, natively, which is really nice for, local municipalities and subsidiaries, that sort of thing. You can build natively over to AWS, but it's only on a credit card. So that's, that's probably a little bit hard for some companies, unless somebody getting points, right? Probably get some pretty serious Amex points. So one of the biggest differences, I think, between the two platforms is billing in Azure is by the minute, right? Compute time is the majority of what you spend your money on, right? It's about 80 to 85% of what you spend your money typically in the public cloud. And billing by the minute is huge, right? Especially if you're taking advantage of like auto scaling of services, right? Where you're bursting up and bursting down. Maybe your company does a marketing ad, you got a Super Bowl's coming up, right? Pretty soon. You have a Super Bowl ad and you put an ad out there and you have to build tons of instances when your ad comes online and everyone's gonna hit your site. Well, you might have thousands and thousands of VMs or, instances running, that sort of thing, and you only need them for 15 or 20 minutes, right? And, by the minute is definitely an advantage to Azure. Both of them charge, and this is pretty much universal with public cloud, data in is free, data out costs, right? That's generally the same, and so it's the same between the two. Now, where it gets a little bit more complicated is with respect to subscriptions and contracts and things like that, right? So over in Azure, we have a few different subscriptions types. The first is pay-as-you-go, which, by the way, it's actually going away. I don't know if anybody heard that, but pay-as-you-go seems to be going away soon. But you can pre-purchase through EAs. They have companies like cloud solution providers, that you can go and buy Azure services from them. Over in in AWS, you of course can sign up and pay as you go. But when we look at these, we have to kind of talk about the discounting structures, frankly, right? Because that's what bigger companies are interested in. So, Microsoft typically signs enterprise agreements and things like that, and as a part of that, you negotiate some sort of discount as well as with cloud solution providers, whoever they might be, you're going to get some sort of a discount. But it tends to be bought as a commitment, right? So, Microsoft, or you'll go to Microsoft and you'll say, I want to use all of these services, I'm going to use them for the next couple of years, that sort of thing. This is about how much we think we're going to do. And then based on that, you'll get some sort of a discount, right? Now, in AWS, they have that sort of relationship, but they also have things like reserved instances and spot instances where you could, by sort of workload, you can say, well, this is our SAP farm, so we know we're going to have this for the next 5 years, right? So you can buy up front those like machines, right? And by saying that, AWS will give you a big discount up front because they're locking you in, basically. And they're not locking you in, you're locking yourself in to that commitment, therefore you get it as a discount. Now, I will tell you that there's probably in the very near future some really interesting things from Microsoft that's coming in this area because they recognize that it's a very advantageous way to buy, right? Now, the other thing that they have is they have something called spot instances, where once again, this is the type of thing that you can buy excess compute in sort of a marketplace, if you will. So if AWS has excess compute, it's just sitting there doing nothing, they'll put it out there, kind of an auction style, and you can pay for compute time at a lesser price just based on the fact that no one else is going to use it anyway. So it's just going to sit there. And so spot instances is another thing that's pretty neat. Now, this last one here on the Azure side that I think is really interesting, and it's more so interesting not because it's good, but it's because people don't realize it, and that's hybrid use benefits. If you have an active Windows Server license and your company has software assurance, you can take that license and say, well, we're not running it on-prem anymore, we're running it in Azure, right? And you can port that license to the cloud, and when you do that, what you're going to pay for is just the base compute price, right? The bare metal. Okay? If you go and just create a Windows virtual machine in Azure, you're paying for the compute and you're paying for a license. Okay? And it's about 45% of the per minute cost is the license, right? So all of you that have Azure VMs running out there, I'll run back and see if you can save your company money, because you probably can, right? I guarantee you there's a lot of you out there that are running VMs where you have a license, you think, well, we have the license, and then you go into the cloud and you're paying almost 40% too much per minute for a VM. That's a significant amount of money, right? So that's definitely something that I would challenge you to go check out. Now, calculators. Both of them have calculators. You can go out and mess around with the pricing. It's not completely one-to-one, the pricing. I think that Microsoft and AWS are just going to be doing kind of the rock'em sock'em robots with pricing for a while, right? That's what I would imagine. But you can go out and you can build a solution, and if you get pretty crafty, you can do some pretty cool things with building your own solution. The one nice thing that the AWS calendar has is because they have those, I actually put it up there, they have those reserved instances. You can go and say, well, what if I did it for 3 years? What if I did it for 1 year? That sort of thing. Kind of like when you look for a car or something like that, right? You can choose your price, choose your financing, or whatever you want to call it. So you can use those to check that out. Of course, the discounting and that sort of thing, you're going to have to talk directly to the company or talk to your reseller, whomever that you buy things from, in order to figure out what your real pricing would be. So let's get past all this money stuff, and yeah. In this one? Yeah, so it is actually. So both of these, the licenses is included, right? Because the default perspective is that you'll need the license. Now what you can do, I'm more familiar with this one. What you can do in here is if you were to say, well, I need like a D5 or I need a whatever, right? You go and you choose some size of a VM. If you choose it as Linux instead of Windows, then you'll see the price, right? Okay? Now, if they put Red Hat in there, that might not be true because you have the option to buy licenses, but just choose I think there's one that just says Linux, and then that's the bare metal price, right? And you'll see it's 45 cents on the dollar or something like that, cheaper per minute. Does that make sense? Cool. All right, so let's move on to some cool, more technology stuff and all this billing and money stuff. Let's talk about identity. Now, this is one of those things where I have to say that Microsoft has it, right? Because, if you think about, from an enterprise perspective, maybe not from a web perspective, but definitely from an enterprise perspective, Active Directory is kind of the de facto enterprise directory that there is in the enterprise these days, right? And what Microsoft has done is taken that, they've created this thing called Azure Active Directory, which is one of the most rock solid and hardcore services in all of Azure. It's done 1 trillion authentications, okay? That's how big it is. And it's used by, they say, between 5 and 6 million customers, right? Because all of Office 365, that's Azure Active Directory, okay? So quick lesson about Azure Active Directory and Office 365 and all that, okay? Have you ever heard the word tenant? Okay, when you hear the word tenant, that means Azure AD, all right? If someone says Office 365 tenant or Office 365 directory, that's an Azure AD, right? How many of you have Office 365? in your company, or you worked with customers, okay? So a lot of us, right? If your customer or your company has Office 365, you have an Azure AD. When you go to spin up an Azure subscription, what you need is you just need the administrator's ID from your Office 365 directory, and you can immediately assign that directory to be the directory for your subscription. Does that make sense? All right? So really easy stuff. Now, what Microsoft has done is, and it's pretty awesome. You can very easily set up, there's a tool called AD Connect, where you can synchronize your on-prem Active Directory with Azure AD, right? So all your objects will go out there, so your users, your groups, and that sort of thing. And then you can leverage those groups out in Azure, right? So you can leverage them to, provision services, you can leverage to give rights, you can leverage them to give, administrators access to do what they do, that sort of thing, the same way you do today. And, the beauty is that, let's say one of those employees leaves and they're an admin or something like that. If you lock an account in AD and it syncs, the second it syncs, everything everywhere is locked, right? So really, really cool stuff. Rich integration for SaaS and that sort of thing as well, and I'm going to show you an example of that. Now, over in AWS, they have an identity and access managed services. They call it IAM. It's strong, it's powerful, you can do amazing things with it, but it doesn't integrate in the same way, right? It doesn't integrate in the same way. And so this is one of those areas where when we teach the Azure for AWS Experts class, all the AWS folks are like, yes, this is awesome. Can we get this in AWS? And the truth is you actually can. There's a way to connect your Azure AD and use it to authenticate and use it to manage your AWS services, right? Because it's federated. And so it's pretty interesting stuff. Now, let's take a look at modern identity. And this is kind of the most common challenge, right? I mean, we all have way too many usernames and passwords, correct? I mean, who knows how many we all have these days on the internet? And in an enterprise, that's extremely challenging, right? It's extremely challenging to provide help desk services, to provision people, to give them access to things, to stay away from confusion. So, using Azure AD, we can synchronize those identities like I was talking about, right? So we've got our on-prem Active Directory that we've invested in the last 20 years. We can synchronize that Active Directory, and then we have one single identity, right? Where we've taken that identity and we've actually cloudified it. That's the kind of word I like to use, where we've taken it to the cloud. So the same user ID, when somebody sits down, they press Control, delete to log on their machine, it's the same ID that they use for something like Salesforce or Dropbox or GoToMeeting or apps that you write that run in Azure or their Office 365, right? That's what you want. You want that one single user ID. And, by having that one identity, it's easy on the user, it's easy on you. And there's actually some really cool features. If you look at, Azure AD as a product, it has different SKUs. One of the SKUs, I think it's in Premium, is, and I love this one. This is my favorite. It's it's self-service password reset with write back to on-prem. Yes, right? That's like the holy grail. Okay, anybody ever sat on a help desk and changed passwords? Yes. You know that passwords are almost 50% or more of help desk calls in some organizations? Can you imagine how bad they are, like after Christmas or holidays or something like that? Right? We're just all morning. It's I'll change your password. Yeah, I'll change your password. Yeah, I'll change your password. Right? And what do we all do for our passwords that are broken? Expedia, Facebook. You click a thing. It takes you somewhere. It sends you a text to your phone, and you're done. Right? Instead of in an enterprise picking up the phone, dialing 9help or whatever it is you dial and wait for somebody and that whole thing. Right? And so this is enabled where you can do that, self-service password, and it writes it all the way back down to Active Directory. Very, very cool stuff, right? So, Azure and Azure and AWS both obviously have, great tools to manage, and there's all these products, and they've got these fantastic portals. I'm going to show you the Azure portal a little bit if you haven't seen it. It's a little bit of a difference, it's funny because some people really like the Azure portal, some people really like the AWS. It's sort of a hate it or don't kind of feeling with a lot of people. you know, I don't know. I just want the thing to work, right? So I'm not really too partial to things like that. But some people tend to kind of like one more than the other. But they are what they are. Now, what we're going to do is we're going to focus now for the rest of this on compute, storage, and networking. Okay, that's what we're going to look at. And so, if we take a look at this, let's go through these, and we're going to do a couple of demos that are kind of cool. All right, so let's get to know this stuff. So networking. So networking at a glance, we've got Azure Virtual Networks, and on the AWS side, you've got Virtual Private Clouds, right? That's what they're called. And that's really sort of the linchpin. It's the central of what you do. It's where, you know, your virtual machines are there, that sort of thing. It kind of is your network that you connect to and work with. As far as content delivery networks, Azure has the Azure CDN. Over in AWS, we have CloudFront, is what it's called. Same type of service. Then we have ExpressRoute, which is a direct connectivity into the Microsoft backbone from your location. And then, you know, over in AWS, we have Direct Connect. So you can see these services are a lot alike, right? I mean, the devil's in the details, of course. But, you know, we have a lot of these that are generally the same. And in Amazon, they have something called Route 53, which is, you know, a DNS and a DNS traffic manager, right? Where I can point traffic to go to different data centers, whether it's my data center, you know, on any number of AWS or Azure data centers, that sort of thing. They both have that product. And then for load balancing and that sort of thing, Azure has a load balancer as well as what's known as an application gateway. Okay, an application gateway is, you know, more like an application load balancer, right? Or you might have heard of it as an HTTP load balancer or an application firewall, that sort of thing. Hardware devices that are analogous to this are like a NetScaler, right? From Citrix or a Kemp LoadMaster, something like that. We have the Elastic Load Balancer over in AWS, which kind of does the same thing. Now, the app gateway is also can be turned into a web application firewall, or a WAF, if you've ever heard of that. So you can turn that on, and AWS has a WAF service as well, right? And what a WAF service is it's basically a firewall that can detect different kinds of hostile traffic and actually stop it from occurring again, right? So it might look for, you know, like social security numbers or, you know what I mean, different kinds of attacks that it'll block and sort of self-heal and that kind of thing. And all of these, you know, you're going to get, you know, things like SLAs and that sort of thing, network security groups. The one thing that's a little bit different between the two, I would say, is if we look back up at the top at the VNets and the VPC, you know, when you create a VPC in AWS, by default, it's not connected to the internet, right? So, you know, you have to sort of, you know, you've got to create a NAT gateway, you've got to create some routes and some things like that. Azure and Microsoft have taken more of an approach where they sort of wire it together in the beginning for you, right? To make it a little bit easier, I think, to get started. So, you know, by default, like a VNet has an SNAT set up, it has routes to the internet, all of that, you know, straight out of the box, right? You don't have to worry about creating that on your own. And down at the bottom, you can hit that link and read some more about it. Now, from these virtual networks, you've got private subnets. I just talked about this, routing tables, SNAT, that sort of thing. You can do custom routing. There's something called network security groups for securing things. I want to talk about those in a second. You can do hybrid connectivity with both sides, right? But over in Azure, hybrid connectivity, IPsec tunnels, PPTP tunnels, that sort of thing, as well as, you know, having a dedicated kind of connections for, you know, like DNS, different types of VMs, that sort of thing, and complex routing. Over the VPC, same kind of things, right? You know, you can create your own routing tables, you can force traffic where you want it to go, you can do all that in both of them, right? So they're essentially kind of sort of the same in a lot of ways. Now, network security groups, I want to call this out a little bit for you because it's a little bit different the way it works in AWS and Azure. In Azure, we have this thing called network security groups, and basically this allows you to say what traffic goes where, right? So I can, you know, allow traffic, deny traffic, that sort of thing. You know, like I don't want traffic from the internet talking to my SQL server, right? But I do want it talking to my, you know, PHPs, right? That sort of thing. So I could say, well, I only want traffic from, you know, the network where the web servers are on to talk to the SQL servers, that sort of thing. Like that's the design we're going to do here in a minute. And so, you know, you can go in very easily and create these rules. And you can do deny and allow. And it's really nice because there's lots of pre-configured services, right? So, you know, you can go in there and say,
if you choose like a Microsoft SQL server, it knows, well, then you're supposed to allow 1433 out of the, it's not like these days everything's a Google away, right? But it used to be, figuring out the port of something was kind of hard, But it's pretty nice because they have those in there. You can really quickly kind of configure and secure your networks. And you can configure all this stuff with the portal or PowerShell or ARM templates, that sort of thing. Now in AWS, you have two methods, right? So in AWS, you have security groups, which are stateful for instances, right? So that's how you, say what traffic can get to an instance itself, whereas your ACLs are stateless, and those are for subnets, right? So there's two different things to act in two different ways. In Azure, a network security group can be applied either to a network interface or to a subnet, okay? And that's it. So you're kind of doing the same thing. In Microsoft, they have one thing that you associate, right? In AWS, they have two things that only work with the two things that they work with. Does that make sense? So, it's a little bit of come see, come si, I guess you'd say. So comparing VPN connections. So, we have in Azure, you can do on-prem to VNets, obviously, and you have VPN gateways, that sort of thing. And we talked about ExpressRoute, which is that hardcore connection. Inside of the same region, you can do VNet to VNet peering. So if you had two different VNets, you can connect them hardwired together, right? Without a route, without a gateway or anything like that. Really simple to do. Maybe you had a dev test network and you have a production network. You want to connect them together. A couple clicks and bang, they're up and running, right? Same way over in AWS, right? And so, the connectivity is pretty much sort of like for like. I think that probably the only difference, once again, is that when you're creating that connection, don't forget this, like if you have two different regions and you create a VPN connection between the two, you're going to egress to the internet for that traffic, right? We talked about that earlier. That's always going to be the case. Now, ExpressRoute, this is a super high, fast, secure kind of connection to Microsoft. And what's interesting about this is depending on whether you're going to use MPLS or not, that states whether or not it's like a layer 2 or a layer 3 connection. ExpressRoute is only available in certain cities, right? So these are the cities around the world right now that's available for commercial. And what happens is you as a customer, like here in Chicago, it's one of the ones on the list. This is the way it works. What happens is we're going to get a Metro Ethernet connection from your location to an Equinix data center, basically, right? So to the cloud exchange, right? That's where the Microsoft is peered with them, right? So you get a Metro E from here to there, and then that allows you, then you have the layer 2 connection, and then you're going to set up BGP routes, right? So you do BGP routing is basically how it works, okay? So you'll publish your, get their ASN, publish your ASNs, that sort of thing, and that's how all the routing works. Now, what's great about it is your packets, even going to public Azure services, okay? So think about like Azure Storage sits on the internet, right? Azure SQL Database, those sorts of things. They're public services, and your public IPs never touch the internet. So if you're inside of your, if you go across an ExpressRoute from your network, even to a public service, never touches the internet, even though it's a public IP, right? Because you have a direct BGP route, right? Now, you can do the same thing if you have an MPLS connection. If you have an MPLS connection, it's just going to be a layer 3 route. You're not going to need that Metro Ethernet connection, right? You already have an MPLS cloud. It's just going to create another endpoint. It's like adding in another branch office. It just happens to be the Azure cloud is your next branch office that you've added, okay? Now, the government, we have that for the U.S. There's 4 POPs in the United States. Over in Germany, they have it, and China has it as well, although it's kind of blue. You can't really see up there. But that's the cloud. So let's take a look here. I can stop blabbing so much. We can take a look at and do a quick demo. Does that sound good? Let's look at networking. So what I'm going to do really fast here is we're going to create a virtual network, all right, live on stage. Demo gods, please be there for me, right? So we're going to create an app subnet and a data subnet. And then we're going to create a network security group called Web. It's going to allow our traffic from the outside in. Then we're going to create a network security group called SQL. And it's only going to allow MySQL traffic, right, from the app subnet to the data subnet.
that's the way this looks, so you can look at the rules and kind of read those and see what that looks like. And then I'm going to create an Azure Load Balancer, okay? So we're going to do all of this right now, right here. And let's open up, turn on my mouse. Let's open up, there it goes. The portal, okay? So this is the Azure portal in case you haven't seen it before. Probably all of you have at this point. But I'm going to go ahead and we're going to crank this out, okay? We're not going to mess around very much. I think I created a resource group for us already. Okay, I created this resource group called AWS RG, and resource groups are how you collect and put our resources together. So I'm going to first do a virtual network. So virtual network. So we're going to create a virtual network. Find this here. I'm going to use Resource Manager. And we're going to call this AWS VNet. And I'm going to change the IP space to be 10.0.10.0/16. So just a flat, regular 10.0 network. I'm going to call that first subnet apps, 10.0.1.0/24. So we're going to use a CIDR mask of /24. And we're going to, that's my subscription. We're going to use AWS RG, and we'll let this go. Now, the one thing, when you're creating a virtual network, when you're creating like a subnet in Azure, Azure holds back 5 IPs, okay, for infrastructure, right? Normally, when you do CIDR, you lose 2 IPs on a network, right? You lose your default gateway and you lose your broadcast address. Well, you're going to lose both of those, and then you lose 2 for a DNS server and things like that. So remember, it takes 5. So if you want to CIDR way down and you want to be skimpy with your IP addresses, you might run out pretty quick, all right? So we've got our first subnet here. So we've got 10.0.1/24, and that's called apps. Now we need another one for our database server, right? Because we said we want to be secure. We want to secure those. So here's data 10.0.2.0. I'm not going to do a security group yet. We're going to use the default routing. So that's going to go ahead and create. Should only take a second. So there it is. So now we've got our two subnets in our virtual network. So let's go back now. And we said we wanted to do some network security groups. So we got our network security group. We're going to go ahead and create the first one. Say create. And I said I was going to call it Web NSG, right? And we're going to use an existing resource group, AWS RG. Same region. Go ahead and create that. While that's creating, I'm going to go ahead and create the next one. So security group. And we'll call this one SQL NSG. And we're going to use the same resource group here, AWS RG. And I bet our other one is done. Well, not quite yet. All right, there it is. So here's the Web NSG. So if we pop back really quick, what we said we wanted here was we said we wanted, come on, hello. We wanted the web to be able to talk, or we need to be able to talk into web, right? So we're just going to do 80, right? Just going to do 80 in. Hello. Well, you can see that, but I can't. Hold on. All right, so here we are. So I'm going to create an inbound rule. Say add. We're just going to call this www. So source any. We want anybody on the internet to be able to get to it, right? We're going to choose, and this is that list I was talking about. Look at them all. Postgres, CouchDB, Cassandra. You think you'd ever see that kind of stuff on a Microsoft product before? How about that, right? So we're going to choose HTTP. Port 80 with allow and TCP as the protocol. And while that one's updating, let's go over to the other one. We're going to go to that SQL. Here's our SQL NSG. And for this one, it's going to be a little bit more complicated, right? So for this one, we're going to say MySQL. And we're going to say from a CIDR block. So we're going to say what block of IP addresses can talk to this, right? So we're going to say here, this is going to be 10.0.1.1.0/24.
So that would be any of the 251 addresses on that network would be able to do this. And we're going to choose MySQL. And 3306 is the default port for MySQL. And we're going to say allow. And we're good, right? So it's going to create that rule. Now, let's go back over here. So we've got our VNet. We created the two subnets, and we created the rules, right? So last thing we said was we need a load balancer, right? We need load balancers. So we'll go ahead in here, and we'll do a load balancer. And see the load balancer. And by the way, you know, the Azure load balancer is fantastic. And what's interesting is, you know, people will say, well, okay, well, what do I do about my load balancers, right? Like I'm used to using an F5. Anybody use like a F5 or something like that? You know, of course, right? Well, what you actually do, and I'm going to call this AWS LB, and we'll say this is a public. What you're going to do is when you're going to use that F5, you'll actually put this Azure load balancer in front of your F5s, and I'll explain that to you in just a second. Let's call this the AWS LB, and oh no, this is the public IP. Giving it a public IP, a static one. Go. And that's pretty much all I need to create this. So when you have any kind of load balancer, you always want high availability, right? Azure with their load balancer, with this load balancer right here, it's by default, it's highly available. You can't configure it, but it is highly available, okay? Now, if you were going to implement an F5 in Azure, what you would do is you would go to that Azure Marketplace I was talking about, and you can, you know, use their templates to put an F5 that's running in a VM, right, out in Azure. You deploy two and connect them as highly available in case one of them goes down or you want to, you know, patch it or something like that, right? And you put the Azure load balancer in front of that, right? So the traffic comes into the Azure load balancers, and then it will watch to see which one of the F5s is the active one, and then all of your traffic would, you know, work the way you normally would with an F5, right? Okay, so this went ahead and it created the load balancer for me. Let's go back and evaluate what we just did there in just a few minutes. So we have an Azure load balancer called AWS LB. We've got a public IP for that, right? That's how we're going to address it. We've got AWS Net, which is our virtual network, and we have those two subnets, apps and data. And then we built two network security groups for each one of those. The web one allowing AD in from the internet, right? The SQL one allowing 3306, but only from the IP address block, which is the app subnet. Cool? You like that? Now let me show you one other quick trick, and this is where you guys are going to get involved. So I'm going to go to the IP address. So this is the AWS public IP address that we created for this, and we're going to call this Tech Summit. How about Chi-Town? How about that? Does that sound good? Tech Summit Chi-Town, and that's what we're going to, as long as that's available, and it is, and we're going to save this. And so that's going to be the address that's going to hang out on the front of the internet, right? So that's where, you know, you can, from anywhere on the web, as soon as this updates, you know, it'll update immediately in the Microsoft DNS servers. And you can see there it says Tech Summit Chi-Town, and then down at the bottom, it says .centralus.cloudapp.azure.com. Now, the nice thing about that is that those domains are nice for every single region around the world, right? So we're rolling out to the central US region. If you were in like West US, it would say West US, or if you were, you know, wherever, right? So you can look at those. And then obviously what I would do is in my real DNS name, like let's say I was, you know, Kintoso.com, isn't that what Microsoft always uses, right? If I was www.kintoso.com, then what I would have is I would have a CNAME that points to this, right? And the host headers of the address that I addressed, that's how the website would respond and react, right? It wouldn't say this, it would say www.kintoso, but that's what we would address as that. So when we build the compute, you all will be able to go to this IP address, which will hit the front of that Azure load balancer when we get the compute built. So now what we have is we've got kind of the network plumbing, if you will, is wired up. Okay, so let's go back and let's talk more about, oh, there we go, sorry, we got to do this again. So that's what we built. So now, compute. So let's take a look at the compute. So obviously we've got Azure Virtual Machines and what's known as EC2 or Elastic Compute. We've got container service in Azure and the container service over in
AWS. And these are both interesting, right? They're sort of container management types of systems. And the way that my view on these, at least from what I've worked with them, and I've worked with the Azure Container Service quite a bit, is it takes the hard part about wiring it all together away, right? Have any of you ever worked with Docker Swarm or Mesosphere's DCOS or something like that? It's a fantastic product, but it's kind of hard to get it going, right? And the funny thing is that when you first wire it up and you're first getting it working, that's when the challenging part, and then later you get all the goodness, right, of being able to spin up and down all these containers and do this sort of thing. And that's what both Microsoft and AWS have done here. Now, in the PaaS world, from a compute point of view, we have what's known as Azure Web Apps, right? And Azure Web Apps, there's a few different flavors of them, but they provide you with a way to, once again, only worry about your apps and data, right? So this is a way to serve web pages, serve up applications, that sort of thing, without having to manage a bunch of VMs. And we have the same thing over in the Elastic Beanstalk world. And this really is all about just, getting rid of IaaS, right? It's all about just building an app. And then we have, the Azure Marketplace and that sort of thing, and there's the Marketplace over in AWS. Now, in the serverless world, right, if you've heard about the serverless world, it's become much more popular, right? As people start to write more microservice types of applications and that sort of thing, they're also seeking out ways where you don't need any compute, right? And the only time I want to use compute, or the only time I want to pay for it, is when the code is exercised, right? So if somebody goes to www.contoso.com, that's when I'll pay, right? When the computer actually has to read those pages and send it back to the client, as opposed to right now when I buy a VM and it sits there, right, waiting for people, and I'm paying to wait, right? So we have Azure Functions and Web Jobs and Logic Apps that are kind of in this universe in Azure, and then there's a product called Lambda over in AWS that does the same sort of thing, pioneering the serverless kind of market where I just put my code there, and when somebody hits it, it functions. Now we have Azure Site Recovery and Azure Backup and Compute over in Microsoft. And really the only thing that kind of matches up here is the migration service, which doesn't really match at all, frankly, to those two things. But AWS does have a migration service, and you can use Site Recovery as a migration service, so I think that kind of matches. Now, a few other differences in Azure, you can definitely you can specify a username and password, that sort of thing, a little bit different in AWS. You can say what the machine's name is, that sort of thing. And there are the complications of the Amazon Machine Images, the AMIs, versus VHDs. If you have a virtual machine that you convert to VHD, it can be uploaded to Azure, it can be downloaded to Azure, and it can be used anywhere, right? Whereas with an AMI, if you create a machine in Amazon, you really can't move it anywhere. If you create it on-prem, you can upload and convert it and then pull it back, but that makes your provisioning process kind of tall, right? So just something to sort of think about and that sort of thing. And by default, the VMs are publicly available in Azure, right? So if you just follow the wizard, the thing is going to be hanging on the internet, right? Just so you know, right? Now, this is kind of a like for like view, if you will, right? Where we have, sort of the front to back of public IP, and then VMs in the front, and that sort of thing in the back. One of the technologies here is that you'll see here it says auto scaling group. You can have scaling groups where machines will scale up and scale down over in AWS. The converse of that is a scale set in Azure. Scale sets give you the ability to sort of crank out the same exact image of a VM, and you can do that elastically, right? So, if you put in, how many queries per second or how much processor, that sort of thing. Now, the VM sizes, we've got, there's a lot of VM sizes, and this is going to get worse, folks. I mean, get used to trying to figure out what size VM. It's one of the hardest things to do almost these days. I built this chart, which is kind of an eye chart, but you can take a look at it. There's different types of instances, and some of them are balanced, and some of them are compute optimized, some of them are more optimized for memory, that sort of thing. And we list these out, and there's ever more VM series. Microsoft is getting ready to introduce some more VM series, right? And so, you can take a look at this to sort of port your knowledge of what you saw to what's out there. And Microsoft has a great page about instances. It talks about how each one is optimized, that sort of thing. It's one of the ones down here. It's this one right here, the machine sizes, so you can go and read about that. So let's add some compute, right, to our little network, don't you think? We're getting short on time, so let's hurry up and do that. All right, so the first thing I'm going to do is we're going to go back to our resource group, which we're here, and we're going to add a machine in the portal. So we're going to use an Ubuntu 14.4 LTS, and we're going to call this guy WebVM, and I'm going to use a demo user account. Let's create one here. And I'm going to put it in that same RG. I'm going to use a D1 V2, or DS1 V2. These are kind of the general instances, the Ds. Now I'm going to create a new storage account called AWS Demo. So that's my storage account. We're going to put it on that AWS VNet. We want it to be on the apps. I don't want it to be available to the public internet, because we're going to publish it via that load balancer, right? Network security group, I don't want that either. The extensions, I'm actually going to run an extension, and I'll show you the script. This is called the custom script extension for Linux, right? And what this is I'm actually going to choose a file. Here it's called apache.sh. It's a little script that I wrote that installs Apache and creates a page, right? So the machine's going to come up, it's going to provision, and it's going to run the script. So when it comes up, it should be fully configured. I won't have to do anything to it at all. So we got that extension there. The next thing we're going to do is we're going to build something called an availability set. An availability set is basically a way to tell Microsoft's Fabric in Azure to not put our machines on the same fault domain or the same rack, if you could think of it in your mind like that, right? You know, in Azure, in any data center, you know, we're going to build at scale hosts. It's commodity hardware, right? You know, you're going to have a top-of-rack switch. You got, you know, some single points of failure and that sort of thing. And so availability sets give us the ability to tell Azure, hey, I've got 2 servers, don't put my eggs in one basket, right, is basically the idea. All right, so that machine's going to go ahead and configure, and you saw how easy that was, right? I mean, you know, boom, boom, boom. Once you know how to do it, boom, boom, boom. But even better, let's also take a look here, and I'm going to open up Visual Studio Code. And notice I'm doing all this from my Mac, by the way. I don't know if you noticed that or not, okay? I'm not on a Windows box. So here, this is Visual Studio Code. Visual Studio Code, once again, it's an open source product. It's an awesome little editor. You might be familiar with like Atom or something like that. It's like that, but on steroids. It's really, really cool. And the nice thing is you can actually open the terminal down at the bottom. So I've got the Azure command line tool up and running here. You see I'm running a bash. It says bash 3.2, right? So this is the Azure command line tool, so I can do like a Azure VM list. It's going to show me like what VMs I have in my you know, my subscription, that sort of thing. So we've got some stuff out there. Look, you even see that one CSS creating, my WebVM one. It's busy doing that out there. So what we're going to do is first is I'm going to run some of these commands from here. And obviously I wrote these earlier, but you know, the first thing I'm going to do is, hello, didn't copy it. Copy, paste. So the first thing I'm going to do is we're going to create a NIC, right? So this is for our MySQL server, and you can kind of see the command there. It says, you know, the name of the machine, and we're going to AWS VNet, the resource group, and that sort of thing. And I love the CL. Oh, what? AWS RG. Oh, there's a bug in that. There's a bug in that line. Hold on. It's not. What's that? That shouldn't matter with this though. Azure NIC create blah blah blah. What was the error? What we just said? Oh.
Oh, it was net instead of VNet. Is that what you're saying? Oh, okay. Thank you. Debugging from the crowd. I love it. And you're right. Debuggers. Good job. Okay. So now we'll have to do that with every line. Yay. Okay. Okay, so that was my NIC, right? And now I'm actually going to create the VM. So we don't have to change that again. So on the VNet, it should just be AWS. It was like this, right? AWS net. MySQL, da la la. That's the same command, Dan. Come on. Ah. Come on. Sorry. Try to use the big kid mouse for a minute. Okay, so we created that. Now what we're going to have to change. Oh, no, I won't. Nope, this should work. So now we're going to create this MySQL server. And in the fear of running out of time here, I'm going to open another window. It's going to be small, but it'll still work, sorry. I'm going to run the other one as well. AWS net. So this is the second VM is what I'm creating in this other window. Okay. And I missed the A, is that what you said? Well, that's fun. Never let them see you sweat, man. Right? All right, that's an error, that's fine. And then here. Doop. Okay. I did call it WebMV. That's okay. That doesn't matter. So now what's happening is, right, so this machine's creating a VM. Let's see if our MySQL machine, so it's still creating. So I wanted to tell you about that script extension, right, while this is working. So let me open really quick the file that I was talking about. So there's two files here. The first one was this Apache file, right? And you know, it's pretty simple, right? When it comes up, you're sort of root, because everything that's accessing is it's using the Windows Azure agent, basically, right? The Azure guest agent. And so, you know, it's like a fresh Ubuntu VM. So we just do an apt-get, we do an apt-get update, do an install of Apache, PHP, or whatever. I just echo out a bunch of stuff into a PHP page, right? That I'm going to show you in just a minute. And then down at the bottom, we restart it, right? And so, you know, it's a pretty simple script, but extremely powerful, right? And you can do this with PowerShell as well. If you want to write PowerShell scripts, you can do the same thing. So that was the Apache one. The other one is the MySQL. So like here, you know, I just basically do the same thing, right? So declare some variables, echo some stuff out, do an apt-get install, install MySQL, and create a database and that sort of thing, right? So just writing a simple script, so when the machine comes up, I can provision it, so as soon as it comes up, it's provisioned, it's up and running, it has exactly what I want. And you can do the same thing with other script extensions, like if you're used to using Chef or something like that, if you build a Chef server, you can have, you know, put in the Chef server, and all you'll need is like the PEM file so that it logs into the Chef server and grabs whatever cookbook you want it to run when it first provisions, and then it'll be a node, right, on in your Chef infrastructure. So let's take a look here and see. Okay, so it looks like our VM was created. So I'm going to go back over to my demo, and on this one, you know, when I created the first server, what I did is you saw me add that file. Remember, I added the script extension, I chose the file, and I told it what command I wanted it to run. Here what I'm going to do is do that same thing, but I'm running it from a terminal, right? So obviously you can script all of this. And the difference here also will be, and I'll show it to you, is so it says Azure VM extension, blah, blah, blah. Check this out right here. You see this URL? That's that script, but I put it in Azure storage. So I'm running a script to install the custom script extension, and then the script that it's going to run on the box is a script that I put in Azure storage, right? So look at that URI right there. You see that? So it's installing the extension, and we can watch it here, and then it says obscurittyweb.blob.core.windows.net, and then you see that mysql.sys, right? So I'm pulling files that I dumped up in Azure storage into a blob to run, right? And you can do the same sort of thing, like if you use the Azure Resource Manager templates and you're building machines on the fly using like JSON notation and all that, same kind of thing. You can call this script extension, have whatever script you want to run out in storage, right? And you're good to go, right? And so all of your machines will always come up and run that. So here in a minute, well, actually, I need to kick off the other one too.
So is outbound firewall always completely open for Azure?
No. No, you have to add it via the network security group.
So how because you never did that for your app layer and your DB layer between your subnets?
I created the SQL one. I created so that the app layer could talk to. Oh, I'm sorry. You confused me. You're asking me. The question is outbound always out? It's stateful. So anything that was allowed to talk to me, I can talk back. Direct server return. Does that make sense?
Right.
By default, I don't have to add it.
Initiating an outbound.
No.
That's what you're doing here. You're initiating an outbound connection.
Well, because I'm running as root though. When I'm provisioning it. No, so a VM can, you're confusing me. Can a VM initiate an outbound connection by default? Yes, it has, the SNAT is set up, yes. I'm thinking you're asking something different. Yes, it can. So yes, like this is initiating an outbound. It has a default route. It's all wired up. You don't have to do anything for it straight out of the box.
So in that case, you have to go in and explicitly deny outbound.
You would have to deny outbound. And then on our other VM, where's our other VM? Is it done cooking? Yep. We would do this. We're going to do the same thing, but this time I'm calling the bash script. Okay? So, now, let's take a look back here, because the one last thing that I was going to do is wire up the two web machines to the load balancer, right? That's our last kind of to-do to create this and make this work. So if I go to the Azure Load Balancer, what I'm going to do is this is my front-end web. I'm going to create a back-end pool. So we're going to say back-end, and we'll add machines. And it's going to choose from those availability sets. And when I select the availability set, my two machines are there, right? So I'm going to select those two guys, say OK, say OK. And this is going to add what machines are on the back end of the load balancer, right? Now, once we've done that, there's two more tasks that we need to do. The first is we have to create a health probe. So we're going to create a health probe so the load balancer knows what machines are up. And then we're going to create a load balancing rule, which will basically say, how we're going to balance the traffic, right? So this will just take another couple of seconds. So just to go through some of the last quick slides, because we're kind of running over, sorry about that. This is pretty much what we did, right? We created this universe in our talk. Last couple things about storage. We've got blob storage, files, that sort of thing. You can actually create a file share out in Azure. You've got backup, that sort of thing. All of these pieces kind of one-to-one pretty much talk to each other.
The containers are pretty much addressable from the web, which is great. And it's kind of the, kind of this typical standard sort of thing that you're used to with other pieces. And we have the durability we were talking earlier, right? We were talking about the zone redundant and that sort of thing. There are premium disks as well. So, the SSD-based backed disks are out there. You can read about that stuff. And let's take a last look at this, our little piece here that we had for our lab and see if it's done. All right, let's add the health probes. We'll just call this probe. This will just take a second. The last couple slides, Microsoft has Azure Site Recovery, where you can do data center to data center replication and failover, and this works for Hyper-V, VMware, and physical machines. It's very much workload aware, so your Red Hat, Ubuntu, Oracle, that sort of thing. All of these work extremely well, and they have end-tier consistency, as well as you could do really great no-impact recovery plan testing. You can take a look at these, but they kind of match up one for one in a lot of cases for backup and that sort of thing. But Microsoft, I think, has probably a little bit of a better view on backup. They have a much more detailed backup system called Azure Backup that you can leverage. And you can do that, basically, 99 years right of backup. It's kind of forever backup these days. And you can seed it with offline, and it does great stuff for SharePoint, SQL Server, and VMware. You can even back up ESX hosts and that sort of thing. There's not really a backup service over in AWS. So let's take a look at our lab really fast here, see how it fared. And we go to our lab, what we're going to end up with is, I should have this here. Let's add our last load balancing rules, called a rule. And that should be that. So as soon as this updates, you guys remember that URL we had? Let's go find it. It was AWS, I think I call it Tech Summit Chi-Town. Wasn't that what it was? Here it is, Tech Summit Chi-Town. So we need to wait for that load balancing rule to save. And then if we go over here, hey, there's something, right? So we got to the front page of one of the boxes, right? So the app is called demoapp.php, and this will have to pre-compile the first time. Oh, there it is. So it says command successful, right? So we got connected to it. You can see it says demo, web MV, which supposed to be VM. But if we keep, if I keep hitting refresh on this guy, look there. See, now you see the other one, right? And it completed successfully shows us that it's connected to the database on the back end. So pretty cool, right? Create a little quick lab all based in Linux and scripted and all that stuff by default. So that's the end of my talk. Sorry it went a little bit long, but I hope you enjoyed it. Here's some great links. Like I said, go to our website, Appsgility.com, and there's a code there that gives you 30 days free. Try Appsgility if you try that out. We have the most detailed labs on the planet. I have tons of labs in there about building containers, Docker, container services, Mesosphere. We have everything from ScaleArk to CouchDB to all kinds of really cool stuff that you guys are probably interested in, as well as just the meat and potatoes, learn Azure, get certified, all right? So I hope you enjoyed it. Take care. See you later.